Hi guys, this is the last section in Chapter 3, Section 3.6. It's all about functions. I'm hoping that you've had function work before. You should have. If you're in this course, you should have had function work at some point. But we're going to, review as well. That's what this is meant for. Okay, so what is a function? Well, I'm going to give you some formal stuff and some not so formal stuff, so we'll see what we can come up with here. If I have a line, just a generic line, okay, and I want to write that as a function, what I do is I replace my y with an f of x. These are identical. These two things are identical. This is the equation form, and this is the function form. This is telling me what the variable is. It's an x, okay? And this is going to get more important when we have multivariables. And if any of you are heading into the pre-calc world, very important to have function notation so that we know which variable we're talking about. For right now, all you need to know is that y is f of x, okay? Those are identical. All right, so let's talk about the formal definition of what a function is. Okay, this is your input. Okay, this is your output. I want you to think of it as a machine. Okay, I've got my 2x plus 7 machine. Okay, I've got my input coming in here. I've got my output coming out there. Okay, so if I ask the machine, if I give it 2, it's going to process it in here. 2 times 2 is 4. 4 plus 7 is 11. It's going to spit out y is equal to 11. So what it does is it takes the input, the number that you want to calculate, and it spits out the answer. So this is what you're putting in, and these are all your answers. Okay? All of your inputs constitute the domain. What possible values of x could it possibly take? And all of your outputs or all of your answers are the range. What kind of answers are you going to get out of there? Okay? We also want to look at it as input are all, all of your, like on here, we're restricted to these points. Okay? So all of your domain is this number, this number, this number, this number, like that. The formal definition of a function is for every input, there is a unique output. What does that mean? That means for every x that I put in here, I'm only going to get out one answer. Like, I'm not going to put in a 2 and it's going to spit out 11 and 2. It's not going to give me two different things. So what that looks like is there's one answer. It's not going to give me this one as well. You see how I have the same input and I get two different outputs? This is not a function. Okay, so if I take this one out, then I've got, each one is unique. Unique means only one answer, only one corresponding y value with each x. So taking a look at up here, I'm going to say, first of all, do I have any repeats on my x? No, I don't. They're all unique in themselves. So I couldn't possibly repeat them. So this is definitely a function, because for each x I get a unique y. Okay? What would make this not a function is if I added a point. So let's add a point. Let's say I had that whole list and I added the point 9, 11 in that set. Okay? That's going to screw it up because 9 goes with 8. Can't go also with 11. Okay, that's going to be putting 9 in here and I get two different answers back out. So that would not be a function. So this one, since I've got unique stuff going on in here, this is definitely a function. Okay? I'm going to have to drop this down a little bit. So my domain, I said that was all my possible x values. What could x possibly be? Well, it can be 6, 4, 9, 1, 7, or 3. That's it. Okay? So I'm just going to look through this list and see where are those. Well, these are kind of hard to read. 9, I think they're all these right here. I don't have any negatives on my x values. So I'm going to, eliminate those 3. So I'm just matching up what my x values are with my list down there. And my range are all my possible answers, or all my y values, or all my f of x values. I got -1, 0, 8, 1, 8. 8's listed twice, which is fine. The y's can be repeated. Okay? I don't want to do them twice in here, so I only want to list 1, 8, and a 4. So we have -1, 0, 8, 1, 4. Okay, so I think it's this one. And that's hard to match up sometimes. I have a hard time with 8, 1, 4. That's it. Okay. Okay? So let's see what else we got in here. Same thing. Is this a function? Nope. I can see it right away. I've got 2 going with 0, and 2 is also going with 5. That can't be. Okay? This is definitely not a function. It still has a domain and a range. And you're just going to put in the values for the x here. So you're going to put in, well, let's do this one real quick. 2, 21. Okay, you're putting in commas in between wherever you see a separation. Okay? You don't want to list 2 twice. Okay, so 2, 21, 41, and 49 is what you want in here. Okay, and in the range, you want to just put in all your y values. So we will put in 0, -4. 0's already been listed. Then we have a 5. I'm just looking at all my y values here. And 5 has been listed twice. So that's all we want. Okay, this is definitely not a function because, like I said, the 2 goes with the 0. It also goes with the 5. So every x value has to have a unique y value. This has 2 different y values. This is definitely not a function. Okay? Excellent. Okay, we can do it in table form as well. Remember, every x has to have a unique y. This has, every x has a different y. x3 goes with 4 different numbers. So is this a relation? A function? No. It's not a function. The domain is just 3. Right? And the range would be all of these numbers. I'm not going to put those in. Okay? All right, graphically. We can also look at it as a graph. All right, domain and range. All right, so domain was all the inputs. A line has how many points on it? It has an infinite amount of points, so there's an infinite amount of answers for my domain. So I want to do a range, not this kind of range, but a range as far as a interval. Okay, so it's gonna, I have to say between all these numbers. Well, how far to the left does the line go? Well, it goes all the way down to negative infinity. It never stops. How far to the right does the line go? It goes all the way to infinity. So therefore there's just all the answers in between. So we're in here. We're in negative infinity to infinity. That means we have an infinite amount of x points on this line, and it goes on forever in either direction. It's not capped in any way. Okay, the range. What is the range of the range? Mathematicians like to use the same word for different meanings, so it's very confusing. Well, how far up does it go? We're working on the y values. It goes on forever. How far down does it go? It goes on forever down too. So this one as well has a range that is everywhere. Okay, so the domain and the range go on forever on lines. And then we want to know if it's a function. Well, the easiest way to determine whether or not this is a function graphically is to use the vertical line test. Okay, so for graphs, we'll use the vertical line test. And that says that if I draw a vertical line through any point on that graph, okay, so here's my line. I can do it over here. That did not hit the 0. Well, it doesn't matter. It's just any line. If I draw a vertical line at any point, and I'm only hitting the graph once, then it's a function. See how I'm hitting it just that one time? That means every x has a unique y. Here's one that's not. Okay? Look how many times I've hit the graph. Hit it twice. That means, let's say this is -1. If x is -1, it's corresponding to this y value and at the same time this y value. That can't be and still be a function. So this is definitely a function. And lines are functions. Okay, they're pretty much universally functions. Alright, so this one does not, that's like this one. I'm going to hit it twice no matter where I go. So this is definitely, even if I hit it just twice in one spot and the rest is only once, it's not a function. This is definitely not a function. But it does have a domain and a range. Okay? So let's see, hang on, let's blow this up a bit. How far to the left does my graph go? It goes to 2. It never goes past 2, correct? Does it include 2? Yes, I've got a point here. How far to the right does it go? Well, it goes on forever. So I would want this one here. 2 including 2 to infinity. Okay? That's how far left and right this blue line goes. That's what this is asking me. How far left and right does the blue line go? Well, it goes from 2, including 2, to infinity. Okay? Now it's asking me how far up and down does my line go? Well, how far up does it go? This is indicating that it's going, it's at an angle, so it's going to go to infinity slowly. And it's going to go down to infinity slowly. So I've got all possible values on my y, on my range, from -infinity to infinity. Okay? So this one here, domain, is asking me how far left and right does my graph go, and the range is asking me how far up and down does it go. Alright, now we're going to look at some more algebraic ways of looking at functions. Okay, so we have y is equal to x to the 8th. Is this a function? Well, let's look at it graphically, shall we? I have no idea. X raised to the 8th. Okay, there's my picture. If I were to draw a line through this, let me just draw it down here for you so you can see it a little bit better. You know, this is it's coming in and then it's skirting along really flat and then it's coming back up. If I would draw a vertical line through it at any point, I'm only going to hit it once, so it's definitely a function. So yes, it's a function. And now we need the domain. Well, let's look at the domain. Now this thing is very steep, but if I would flatten it out a bit, you can see that it's, you know, angled. Okay, so it goes on forever to the left and forever to the right. Okay, so that would be, I'm supposed to do it in interval notation. So I'm telling you that it's going to go from -infinity to infinity. Okay, it's never going to have a boundary as far as its left and right goes. Okay. Now, though, if it didn't ask me, but if it asked me for the range, well, it's capped down at 0, isn't it? 0 to infinity. Didn't ask me for that. All right, let's take a look at this one. We can use the calculator again. I said all lines are functions. This is definitely a line. Okay. If I would draw a vertical line through a line, I'm only going to hit it once. So it's definitely a function. And my domain, it goes on forever to the left and forever to the right. Okay, so my domain is everywhere. Good. All right. Let's talk about dependent and independent variables, because that's another way of expressing x's and y's. Okay, which one's dependent and which one's independent? Well, that's a really tough question sometimes to answer. If I have, let's just do a line here. So let's say I have 2x plus 7. That's my standard line, it seems. My independent variable, the one that I can choose values for, is always this one. This is my independent variable. I can choose any value that I want for x, and it's going to determine y. So this is the dependent variable. Now this is a little harder to see when I've got choices, because I could also put a y in for here, but if I do it in function notation, you can see that this is the independent variable because it's here. Okay? So your independent variable is this. I can choose to put a 1 in here, a 2 in here, a 3 in here, and it's going to determine what my answers are. So here, what's my dependent variable? Well, it's all of these, right? Let's take a look at what this is saying. This is a graph of a pool. And down here we have time. Okay, so as time moves on in hours, the pool does this as far as its water capacity in gallons. So let's first of all figure out our scale, okay? We have 125 hours down here, and we've got 1, 2, 3, 4, 5. So this is probably what? 25, 50, 75, 100, 125. So that's the first thing you have to do, is you have to figure out what your scale is. Here we've got gallons, 1, 2, 3, 4, 5. So each one of these is 1,000 gallons. Okay? All right, so let's just take a look at what this is saying. Initially, the pool is empty. Do you guys agree? At 0 hours, there's 0 gallons. Okay, so we have an empty pool. We're going to fill the pool. So after 25 hours, it is 3,000 gallons full. And then it stays full for another 25 hours. Then we start to slowly let the water out. Okay, so at 100 hours, we're down to 2,000 gallons, and we stay there. So that's what this graph is telling me. Okay, that's how I read it. My dependent variable is the y values, okay, the gallons, because as time goes on, isn't this driving how many gallons there are? So depending on how many hours I choose, it's going to tell me how many gallons I have in the pool. Okay, so my possible values for that range from 0. At my highest point, I've got 3,000 gallons. So my gallons of water run between 0 and 3,000. Okay? That's what this is asking me for. So how many hours is the water level increasing? Well, it increases from here to here. Then it's constant, then it decreases, and then it's constant. So it's increasing for 25 hours, right? That's this. So it's increasing for 25 hours. And then it's saying, well, for how many hours does it decrease? Well, it's decreasing in between here. So that's 25, 50 hours, right? It goes over 2x tick marks. So it increases for 25 and then it decreases for 50. How many gallons of water are in the pool after 110 hours? Well, again, that's gonna, we gotta look at our scale. This is 100 hours. So 110 somewhere in here, we don't know exactly where, but it stays constant from 100 to 125. And it stays at 0, 1,000, 2,000 gallons in through this entire interval. So we don't really care where it is exactly here because it stays at 2,000 gallons the whole time. Okay? Nice work. Okay, so now what we're going to do is we're going to be evaluating functions at certain points. So let's say I have f of x is equal to 2x plus 7, and I want to put in x is equal to 1 and see what my corresponding y value is. Well, what I would do is I would put a 1 here. I would crunch this number out. 2 plus 7 is 9, so f of x is 9 when x is 1. This is shorthand for asking you all of that. Here's my function. It says find f of 0. That means, whoops, my function is this, and I want f of 0. That means replace the x with a 0 wherever you see it. That's what this whole thing is doing here, and it's also asking you down here. Another way of saying this is I know x is 0, what is the corresponding y? I know the input is 0, what is the corresponding output? In any case, I just replace the x with a 0 and crunch the number. This is 0. Come on, why did it do that? Darn it. So we have 3. So f of 0 is 3. Okay? It's as if you had this as your function and you put in 0, it would spit out a 3 for you. Okay, so you can do this now. This is going to ask you this many, many times here. Okay, so here we're going to put in a -6 here and here. Now this is a function in y. Doesn't matter. The variable is y, so I'm going to replace a y with a -6. Okay, it's just a different letter. Why they do that right off the bat, I don't know, because it's quite confusing. So if I have f of y is equal to y squared plus 8y minus 10, and I need f of -6, I'm going to put my -6 here, here, I don't have one there, crunch the numbers, okay? I've got -6 squared, -6 times -6 is positive 36, 8 times -6 is a -48, minus 10. And then I can use my calculator if I don't like doing, I'm not good at adding and subtracting, I never have been. 36 minus 48 minus 10. Lousy at it. -22. My husband really gives me crap about that. He said, how can you do calculus and not be able to subtract? I don't know. It's just the way my brain works. And you know what? I have a girlfriend that also has a mathematics degree, and she's the same way. So I'm not alone. But it is weird. It's embarrassing and it's weird. It's just really weird. Okay. G of x is equal to minus x squared plus 5x plus 2. And I want g of p. What the heck does that mean? That means replace the x with a p. Replace the y with a -6. This is what this is telling me to do. So wherever I see an x, I just put a p in. It's as simple as that. Okay? I don't know if we've seen the this key right here. This is my superscript. I don't know if I have or not shown you this yet, but I'm going to do -p, and then I'm going to put the 2 in here, and then I'm going to use my very bottom right corner down, or my right arrow key to get out of that. And then I want to add 5p, and then I want to add 2. Okay? Now if you mess up and put x's in here or any other letter, it won't accept it. So you have to be very careful about the letter that you're putting in there. Alright, so now we have f of x. I'm going to do a bunch of these because these are kind of, for a lot of people, they're very confusing. Okay, here's my function. My variable is x. It's telling me to replace x with -x. Well, I can do that. The hard part on these are going to be cleaning them up. So I've got -4. I replace this with this, plus 6. Well, what's a negative times a negative? It's positive. So you have to simplify. You have to clean it up as much as you can. Okay? So my answer would be 4x plus 6 here. That's how I replace the x with a negative x. Okay? Let's try this one. I've got g of x is equal to x plus 2. I want g of x plus 15. What is that saying? Replace the x with an x plus 15. So that's right here. So I have x plus 15, that's like my x, and then I have plus 2. Okay, so sorry about that, I had to pause it for 1 second. Where were we? Okay, so now we have to clean this up. So we have, like terms here. So we have x plus 17, and that's as cleaned up as I can get it. Okay, but it won't take it. Watch, I'm just going to put it in there. I know. You can't do that. It says, although your answer is equal to the correct answer, it's not in the correct form. Okay? So you want to make sure that you simplify it completely. This is the easiest way to get rid of all of that in there. Is that clear all? Okay? So that's what it's going to want. And, oh, yeah, we should probably do this one. How many more of these do we have? Okay, that's just the last one. I should probably do it just because you guys really don't like fraction work, I don't think. All right, cleaning it up. All right, let me get this up to the top. We've got g of x, negative x squared plus 5x plus 3, and we want to evaluate p over 2, excuse me. So I'm going to replace my x wherever I see it with a p divided by 2. Now here's the easiest way to do this. Okay, put in everything except the x. See what I'm doing? I've got everything in there. I've got the negative sign, I've got the square plus the 5 and the plus the 3. Now instead of putting an x in here, right, I'm going to put this in there. That's your easiest way to start. Okay? That's what it's going to want. All right. Now, boy, this is going to be really a trick on what it wants for the simplification. Well, let's take a look. Let's do something over here. P over 2 squared means p over 2 times p over 2. Okay? P times p is p squared, and 2 times 2 is 4. So I'm thinking that it's going to want something more closely related to that. Okay? I've got this negative sign, so this whole thing is negative. All right, and then I've got this. 5 times p over 2. I can think of this as a fraction as well. So I could do 5p over 2, put it all together, or I could pull the fraction out front, and I could do 5/2 of p. I'm not sure what my math lab really wants here. So let's try 5/2 of p. Plus 3. Now I can also pull out the fraction on this thing, negative 1/4, p squared, plus 5/2 p plus 3. This is the way that I would write it in a test. This is probably the most proper way, but I have no idea what it wants up in here. So let's try it. So we've got a negative 1 divided by 4. And then I want my p. I want to square it. That sounds terrible, doesn't it? And then I want to add, I want my p. 5/2 p plus 3. Let's see if it takes that. I like it. It does. Okay. And then, well, play around with it and see. Sometimes, this is exactly the same. This is the same. It just depends. If it says, although your answer is correct, then just keep playing around with the form. Okay? Oh, we're almost done. We're almost done. Yeah. What are we doing here? Oh, these, I don't need to do these for you. These are exactly what we did in section 3.4. Okay, how do you graph a line? Well, if you don't remember, go back to that section. Okay, we've got y-intercept, slope. I could put it on my calculator and find points. I know what the domain and range are because those are in the earlier parts of 3.6. So this is just kind of combining 3.4 with the earlier part of 3.6. That's it. And I think you have a bunch of these. Okay. Let's do, well, no, I think you're good. I really do. This is y is equal to 2. Okay, that's one of your horizontal lines. Okay. This one's too easy to do together. It's just ridiculously easy. She charges $2.50 a mile, so we're supposed to, if you go 0 miles, you get charged what? Nothing. If you go 1 mile, you get charged $2.50. If you go 2 miles, you get charged $5. Okay. And let's see. The thing that I want you to do here is to label what you have. Which is which. That's the only thing that's difficult about this one. And that's not even difficult at all. Okay. Input, output. The function h described by this equation can be used to predict the height in centimeters of a woman whose humerus, the bone from the elbow to the shoulder, is x centimeters long. So this is your centimeters in length of the humerus. That's all of your inputs, and what it does is it says it can predict the height of the woman. Centimeters in length of the bone, let's say, and the height of a woman. This is the independent variable. Okay, the bone is going to vary in length, and that's going to determine, or it's going to be dependent upon, the height of the woman. So if we know that the humerus is 33 centimeters long, we're just going to put a 33 right in there. Calculate out the height. Bing, bada, boom. Pretty simple. And I think that's all there is. That's it. So that's chapter 3 in a nutshell for you guys. So again, to review, what you should be doing is finishing your homework, doing the review problems, making sure everything's set. Take that quiz and see what you did right or wrong. And when you feel comfortable and you fixed everything, take the test. Okay? The test, it's not difficult or anything. I just took, every single test question is a homework problem. So if you've got your homework nailed down, you're good to go. So best of luck, and I will see you for the next chapter.